Alright, in this tutorial I'll do a quick video of what a Vornoi diagram is and what it's used for. So a Vornoi diagram basically, let's say we have a number of post office sites. So let's say there's a post office here, there's a post office here, there's a post office here, here, and let's say that we're somewhere here and we want to know what's the nearest post office. Well, we could compute the distance to every post office, and once we compute the distance to every post office, we can then figure out which one is the nearest post office to go to. But there's a better way. We can have what's called a Vornoi diagram beforehand and then know which cell we're in. So for what a Vornoi diagram for this might look like is something like this, that, 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 that. So notice what I'm doing here is basically kind of saying, drawing this line halfway between these two, this line halfway between these two, this line halfway between these two. Why is this? Because let's say we were here. So the closer one to go to would be this. But if we were here, the closer one, sorry, this was not a point, was it? Let's just make it a point for now. So if we were here, the closer one to go to would be this. So we can create cells like this around each of our points. So let's draw a little halfway mark in here, in here, in here. Already have this one. Between those, maybe right about here. So we're going to end up with something like so. You know, maybe my diagramming might not be perfect, but once we know this particular diagram, which we call Vornoi diagram, if we are here, we know the closest post office to go to is here. If we're here, we know the closest post office to go to is here. So it's kind of dividing up the entire place into a number of cells. These open cells, if we connect the sites, we call these post offices sites. So if we connect these sites on the open cells, we get something which is called, so just like that. So this dotted structure is called the convex hull. And it's related to solving convex optimization problems, but we won't get into that. We're just keeping it to the geometry here and keeping it relatively simple. So now you've seen what a Vornoi diagram is and what its convex hull looks like, what is a site, and these are called edges, and these are all called half edges. Now, another interesting geometrical thing is, let's say that we were to draw on a plane here some, let's say, point, and we had like a parabola here, So there's a tangent line here, a tangent plane. And let's say we had a bunch of web sites. So this is 3D, right? So you have a bunch of sites. Each of these sites on this 3D paraboloid structure corresponds to some kind of a plane. And all of these planes come down and they intersect. And this intersection here, created by these tangent planes, the interesting thing is it also comes out to be the same as the Vornoi diagram of those sites. So this corresponds to some theorem, but geometrically that's what it means. These Vornoi diagrams can be useful for how robots might find their locations, or for planning a business where you want to plant your sites, in which case you would do the reverse. You would know like what are the different areas and how you want to place yourself in terms of where your stores are or something like that. It can be useful for map applications to figure out which is the closest location you would like to go to, and so on. And there's other theorems about the maximum number of edges and things like that, which I won't get into in this video. But you now have an introduction to Vornoi diagrams, V-O-R-N-O-I, diagram. And in an equation, you might see it abbreviated as Vornoi of a set of points or set of sites. So that's it. You are now introduced to Vornoi diagrams.